In this video, you will learn about the two important issues in probability. The one is either the events are certain or impossible events, as most of us are confused to identify either the events are certain or impossible. Similarly, if the rule is related with the additive, then which is the suitable problem? Either it is mutually or the non-mutually exclusive. Most of us are confused to identify mutually and non-mutually exclusive events. So after watching this video, your concepts will be clear about these two issues. So how we can differentiate certain and impossible event. Similarly, how we can differentiate mutually exclusive from the non-mutually exclusive, or how we can choose an appropriate additive rule, and how we can calculate the probability of certain and impossible events. So let us start with the certain or impossible event. So here we can see this is a spinner, and this spinner has four equal sectors colored yellow, blue, red, and green. So if we want to find what is the probability of landing on purple after spinning the spinner, here you can see the absence of purple color. Purple color is not present in the spinner. So we can say this event is the impossible event, as event does not exist. So how we can calculate the probability? As all of us know that the formula to calculate the probability is favorable outcomes divided by total outcomes. So here the favorable outcome is the our event of interest, which is the purple color, and purple color is absent in this spinner. So we can say 0 over 4 is equal to 0. The probability of landing on purple is 0. So this is the impossible event. We cannot find this probability because event doesn't exist. So whenever the event doesn't exist, we can say this is impossible event. Now let us take another example. Here a teacher chooses a student at random from a class of 30 females. What is the probability that the chosen student is a female? Here you can see in female class student. So here all the students in the class are female. So teacher is certain to choose a female. This is known as certain event. So the probability is 1. Whereas in previous experiment, you can say no outcome exists, event doesn't exist. So this is impossible. And when event completely exists, then this is known as certain event. So now you can differentiate certain and impossible event when the event doesn't exist and the probability is 0. And when event completely exists, then it is a certain event and probability is 1. So let us take another example, which is a standard deck of 52 playing card. And here we can see the distribution of cards, which consist of 4 suits: heart, club, diamond, ace. So in each suit, we have 13 cards, name as Jack, Queen, King, Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each suit have 13 cards and total are 52 cards. Here you can see Joker is not included in 52 deck of playing card. So if someone wants to find what is the probability that the card chosen is a Joker card, this is understood in these 52 playing of deck card, Joker is absent. So this is impossible event. Again, we can say the probability is 0 as Joker is not present in 52 playing cards. So probability is 0, event is impossible. So we can define the probability between 0 to 1 and differentiate it as if event is impossible, then probability of any event is 0. And if event is sure event or the certain event, then the probability is 1. And if we have two events and probability of one event is greater than the probability of second event, then we can see the probability which have the event which have greater probability is more likely occur than the other event. And if both events have the same probability, then we can say they are equally likely to occur. And if probability range from 0 to 1, then we can say the event is uncertain. So on these line, we can differentiate or define the probabilities in terms of event. So the second important thing in rules of probability in which most of students are confused is to differentiate mutually exclusive and non-mutually exclusive events. So here is a rough rule of thumb by which you can easily differentiate these two terms. As if events are disjoint and there are no common point in events, then you can say these events are mutually exclusive. And if events are joined, they have some common points, then you can say the events are non-mutually exclusive. Even though the meaning of mutually is common, but we have the exclusive word joined with the mutually. So when we combine the mutually exclusive term, it means the absence of common portion. So whenever we have disjoint events or disjoint sets, we can say these sets or events are known as mutually exclusive, as there is no common point, no common portion present in this. Whereas whenever we have two events which have some common portion, which have some common points, or the occurrence of common portion is present between events, then we can say this is non-mutually exclusive. Non-mutually exclusive means presence of common portion, whereas mutually exclusive means absence of common portion, because we combine exclusive with the word mutually, and here we combine non-mutually exclusive. So we can differentiate these with the joint and disjoint sets. Let us take some simple examples of these two, how we can differentiate. Here you can see the formula, how we can calculate or apply the additive rule whenever we have the mutually exclusive events. Mutually exclusive events, let us start with two events. Two events are mutually exclusive if they cannot occur at the same time. Means if we have event A and the other event is B, then we can say event A and event B are mutually exclusive if they occur separately. If they haven't any common portion, if there is no common portion exist, or they cannot both occur at the same time, or we cannot find the common portion from these two, or we can say A and B is 0. Probability of A and B is 0. Then the events are mutually exclusive. So this is the type of additive rule. So we have OR to join these events. So you can say probability of A or B can be written as probability of A, and or represents sign plus in probability. So and represents sign of multiply. Here we have or, so we have to simply add the probabilities of these two events. So this is mutually exclusive events formula for two events A or B. And similarly, for non-mutually exclusive events, we have some common portions. So the formula is differentiate here with this common portion. As when we count the sample space of event A, we calculate the probability of A. It contains the common portion. And when we count the event B probability, it also includes this common portion. So to overcome the double counting error, we have to subtract once this common portion. So this rule is known as non-mutually exclusive events, in which we have the probability of one event plus the probability of second event minus common portion. Because if we doesn't subtract this common portion, then probability can be greater than 1, which is incorrect statistically. So we cannot find accurate answer of probability in case of non-mutually exclusive without this term. So we must have to subtract this terms once to overcome the double counting error and to get the accurate answer. As you can see, when we calculate the probability of A, this common portion is also included in this. And when we calculate the probability of B, this common portion is also present here. So to overcome the double counting error or to subtract it once, we have to need this factor subtraction from this formula. So on by using this formula, we can calculate non-mutually exclusive events probability. So let us take experiment. A single card is chosen at random from a standard deck of 52 playing cards. What is the probability of choosing a 5 or a king? Now you can say the possibilities of this experiment can be the card chosen can be a 5, the card chosen can be a king. But 5 and king cannot occur at the same time. As if you remember the distribution card slide, where you can have 4 suits and each suits have 13 playing cards, and each suit have 1 5 and 1 king. So 5 and king cannot occur at the same time. So the 5 card haven't the king card. So these two are different cards. So here we haven't any third possibility. So this is the example of mutually exclusive, because here we haven't any common portion. The sets are disjoint. Now let us take another example. A single card is chosen at random from a standard deck of 52 playing cards. What is the probability of choosing a club or a king? Now you can see here we want to choose a club card and also a king. So the possibilities can be the card chosen be a club, the card chosen be a king, the card chosen can be a king and a club. Because in each suit we have king, and the club card is also have king card. So in this way you can see the presence of common portion exists. So this is the problem of non-mutually exclusive. We cannot say this is the experiment of mutually exclusive, because here the common portion is present, as the card can be a king as well as a club. So we can see this is the problem of non-mutually exclusive or the joint events. Now, in experiment 1, you can see card cannot be the same, so mutually exclusive. And in experiment 2, you can see the card can be both. So this is the non-mutually exclusive problem. Now take another example. A single 6-sided die is rolled. What is the possibility of ruling an odd number or an even number? Here we can see the appropriate rule is additive rule, because we have or to join these two events. So now we have to judge either this is the example of mutually exclusive or the non-mutually exclusive. So for the purpose, we have to write the outcome of this and outcome of this event. Here we have two events. One is the outcome are odd and the other is the outcome are even. So this all tells us the suitable rule for this problem is additive. And now we have to choose either it is mutually or non-mutually. The joint and disjoint differentiate us about to choose the appropriate rule, either we choose the mutually or non-mutually exclusive. So let us write the possibilities of this experiment. The possibilities of this experiment can be the number rolled and odd, the number rolled and even. So you can see the even and odd numbers are different. They cannot occur at the same time. So this is the example of mutually exclusive, because they cannot occur at the same time. Now let us take another example. A single 6-sided die is rolled. What is the possibility of rolling a 5 or an odd number? So here again, we can write the possibilities to simplify the problem. As here again, we have the word or. So this is the problem of additive rule. So to choose an appropriate rule, either it is mutually or the non-mutually exclusive, we have to write the possibilities here. So write the possibilities. The number ruled can be a 5. The number ruled can be the odd. The number ruled can be a 5 and odd. Uh, Here note that the number 5 is also the odd. So you can see the common portion presents here. So this is the example of non-mutually exclusive event, as this is the problem of joint set, as the number can be a 5 as well as odd number. So let us take another example to clear our concepts more. A single letter is chosen at random from the word school. What is the probability of choosing an S or an O? Here, we want to select letters. The letter chosen can be an S, the letter chosen can be an O. You can see S and O are different letters, so they cannot occur at the same time. So this is the example of disjoint set. As you can see here, the sets are mutually exclusive. This is the example of mutually exclusive event. So if we want to see what is the probability of choosing an O or a vowel, you can see this example becomes non-mutually exclusive. Whereas when we discuss this example and we choose two letter S or O, then this is the problem of mutually exclusive. But on the same word, if we choose the letter O or a vowel, this becomes the example of non-mutually exclusive event. So this is the example of non-mutually exclusive. So you can see the problem is same, just if we have to change the letter which we want to find the probability, then it becomes the mutually or non-mutually exclusive. So we can decide this on the nature of problem either when we read it. So here we can conclude. Mutually exclusive events, if we have two events A and B and they are disjoint or they occur separately or there is no common portion between these two, then the events are known as mutually exclusive, like this one diagram. And two events, if A and B, and there exists some common portion between these two, then two events are known as non-mutually exclusive. And here you can see the reason why we subtract probability of A and B from this expression. As you can see, when you find the probability of A, this whole circle includes, including this common one. And when you calculate the probability of B, again, this common portion included. So if we doesn't subtract probability of A and B from this expression, then probability might be greater than 1 and this portion includes 2 times. So to overcome the double counting error, we have to subtract this ones from the formula. So hope so your concepts will be quite clear about these two terms, when the events are certain and when we can see the events are impossible. Simply when event doesn't exist, it means the event is impossible. And when events exist completely, then we can say the event is certain event. And when events are joint, they are non-mutually exclusive. And when events are disjoint, there is no common portion between the events, then they are mutually exclusive. Thank you.